Hello out there, viewers. I'm showing you the front end of a boiler that's been in our home for quite some time. I say that because when you see this piping network in front of you here, the actual construction and layout of this piping pre-existed my ownership of the house. However, in the course of 23 years, I have done some work on this thing. Not much in the way of the copper pipe work, but I'm going to make this video because I'm really looking to pay it forward for all of the things that I have personally learned on YouTube through people who have generously devoted time to making videos, whether they were professional or amateurish. And I certainly would place this video in the amateurish category, both from the standpoint of camera work, probably audio, you name it. So if the camera work isn't perfect or the audio is a little bit off for what I say, please forgive me. I am just trying to pass forward things that I have learned over the years. I was a maintenance electrician many years ago and have learned through my own hand how to work on mechanic type things, and that includes about everything. And I've been quite capable of dealing with this boiler over the time we've lived here, such that the only thing we actually had replaced by professional was the gas valve. And the gas valve is now over 20 years old, and I'm having questions how much longer that will last. The boiler itself is marked as a crane boiler. I'm going to guess that this boiler was put in at the time this house was built, which makes this boiler just about almost 50 years old now. It has had problems, not the actual fire part of it, but all the other accessories one way or the other. Early on in our time here, I actually replaced the high limit switch, which is nothing more than a sizable pencil-like object that is inserted into the water jacket to measure the actual temperature of the water jacket. It's really just a cutoff switch. But I'm trying to keep this to current things. I have just replaced a number of items on this boiler. What really started this project was we had an old B&G circulating pump. It was probably known among the heating people as one of the best or better types of circulating pumps you could have. It certainly did its job, and the one that I'm showing you here, the bearing assembly, is still in good working order. I couldn't find anything wrong with it. I played with the shaft the whole bit, and this thing isn't even that old. And I'm not sure if the problem with it has to do with the apparent quality change in things you buy nowadays, because these were reputed to have lasted a long time, and this one here isn't 10 years old. What started this current project was that we had an old GE motor that was running this bearing assembly, and that motor was very quiet, ran very well, performed flawlessly for all the time it was on here. And then last winter, or actually it's been a couple of years, I take it back, the starter switch started to hang up because the contacts on it were pitted and virtually burned out. So what happens when that happens is that the motor will start up, but the starter will not disengage, and that's like running an additional coil in the motor. And I won't try to explain that for you non-electrical type people, but effectively it'll just burn out the motor, or even go further and possibly cause a fire. The motor will generally make some noise, do some kind of weird stuff, but what I ended up doing was putting another motor on the system that I got off of eBay, and that motor itself, I couldn't quiet it down. It just kept making a lot of noise. It was a perpetual nightmare because it would just rattle the system, and no matter what I did with it, and I did a lot, I eventually decided the motor was a piece of junk. You really don't get much for $100. Anyway, I bought another motor from what I thought would be a place that, provided good equipment, since they had dealt in electric motors. And unbelievably, that motor was made by the same people who made the motor that I had a problem with. Meanwhile, I tried to get the GE motor repaired, but no matter what I did in searching for the parts, it was discontinued. The motor was probably in excess of 30 years old. And when I put the second motor on here, that one too gave us some headaches with noise, vibration, and everything else. I don't want to even get into it. Finally, I decided to do some internet research and came up with an idea of replacing the whole assembly with a Grundfos Brute pump, which is what you see in the foreground here. I've just finished installing this several days ago after getting the rest of the parts I was looking for, and I've tested this out now several times, and I just am astounded by how quiet this system is and how well it works with this pump. There's a lot of chat about how these things don't last or do last, whatever else, but just for the apparent super quiet operation of this pump, I'm sold on it. It's also a 3-speed job. The switch is mounted on the back panel of the electrical box here. This is really the only sensible way I could install this one, because if I turned it around 180 degrees, it would be sitting right over the gas valve and pretty much right in harm's way as far as the heat flow from the burner area. So I went ahead and installed it like this. It puts the switch a little bit in an awkward place, but not really that awkward to reach. Anyway, I also had installed some years ago a pump switch, which this boiler didn't have, and that allows you to turn the pump on by itself. My main reason for doing that, to operate the pump, which it is running right now, and you don't even hear it, is that if we have a power outage in the wintertime, I'm more inclined to believe that operating the system with water flowing through certain areas of the house, and when we have pipes under the floor of a slab in a couple places, one in the garage, that the lines will not freeze. You can't freeze moving water, I hope. Anyway, the other reason for the switch is obviously you can run the switch you can run the pump 100% of the time, which many people do on these systems, but I do not do that. In other words, the pump comes on when the system calls for heat, and that's how it works. I also replaced the pressure relief valve because the one that was on there was obviously the original, and as much as it didn't look bad, it did leak a little bit, and even though I thought I could correct that, the thing is just old, and at some point you just got to give up and realize it isn't going to be like new anymore. So among that and the drain tap valve down here, which we had a problem with a little bit, so the reason for the cup here, but I don't really need that anymore, I did replace parts. But by far the most important part that I replaced on this system was this pressure reducing valve that you now see I'm focused on. This valve on a boiler system is responsible for lowering the house water pressure down to the pressure that you're going to use on your system, which in most cases for a 1.5 story house is going to be about 12 pounds per square inch. You may need a little bit more than that if you have a 2-story house, etc. That's all explained somewhere else. I won't get into that. The thing I wanted to mention was that I took the other one off and there was really no way to service it. I also dismantled it a little bit. As you know, there's a diaphragm in the top, and the cone section is basically contains a large spring, which is the reason for being able to adjust the pressure. Anyway, what I wanted to show you was on the inlet side of this thing, the thing was virtually clogged. It had corroded up in there. I think that's a good picture right there, I hope, of what I'm looking at. I began to believe that the problem started with a water heater we had. I don't want to mention any names, but there was a class action lawsuit against the company that made a bunch of water heaters that just fell apart after a couple of years of operation. Well, we were one of those people that bought that type of water heater, and the guy that took the one out that was bad showed us right in the driveway that the interior of the water heater just dissolved. It was just pumping out gunk through the drain, and I think that gunk went into this line. You might say, well, how would you get water from hot water heater into your line for your boiler? Well, I actually have two lines coming in. I have the cold water line here, which is shut off, and I have a line dropping down from the water heater inlet line because we have soft water and I run soft water in the boiler. However, this is a cold water line. It's not on the hot side of the water heater, but in the world of plumbing, anything can happen, I'm sure. But just the same, that was the story on the pressure valve, and that's a key component of your system, because if that plugs up or fails, one or the other, your boiler will either starve or your system will overpressurize. I would think that it's probably going to be the first of any case where the water is just going to be starved off the boiler, and you don't want that to happen, especially during the winter. Anyway, which is when you use it. I couldn't get the screen plug out of this thing. It was just impossible to open. And inside here there's a screen, a strainer it's called on here. And I can tell by looking in here that the strainer's all just all froze up looking. I mean, it just looks ugly. So I'm really glad I did replace this. This is what you call the basket case of this regulator. This regulator was probably at least 30 years old. It might even be original. I don't know how it could have lasted that long based on internet stuff I've seen, but that's how old it looks. Anyway, that's pretty much the gist of this video. I had a problem with the Tridecker gauge, or whatever that's pronounced. It seemed like the pressure side of it was a little bit off by 10 pounds. That probably was compounded this problem with this valve, this reducing valve. And so the pressure is not accurate. It reads 10 pounds higher than it really is. So what I ended up doing for test purposes, I stuck this El Cheapo, what was really a fuel gauge on here. It's just a pressure gauge on a plug out that I had taken out anyway, and I get a reading right now of 12.5 pounds, which is beautiful. It goes up about a half pound when the system's running, which it is right now. If I turn it off, it'll drop. Out of that opening was one of these air vent jobs that I had bought a replacement. The other one looked pretty ancient. This is a long time ago, but it was set up where the plumbing looked like this. It actually looked like the air had to go down, or was down, to go up in this thing. It wouldn't work. It was physically impossible to make it work. What I ended up doing is taking off an old zone valve on this system and putting this larger B&G vent on here. That solved all the air problems in this system. I think some of those air problems are probably caused by low water pressure, caused by a faulty valve. So if you have one bad component on a system, it can very well affect the operation of everything else, and that's what I'm learning from this operation. And I have a lot to learn. But for right now, everything looks real good. The only other component on this thing that possibly for terms of safety and everything else is, I don't know how long this gas valve is going to last. Everything else checks out fine. A little bit of the insulation inside the boiler case broke off above the door, and that's what causes this discoloration, is that it's heating up the steel a little bit more there. But other than that, it's very minor. It's been like that a long time, and it was probably asbestos as far as I'm concerned. So I'm still alive. Anyway, if you ever have to work on some old equipment, possibly like this, you have to also keep asbestos in the back of your minds. It can either be tape asbestos, it can be fiber. It looks like a lot of things, except that if it's white and it looks kind of fibrous, you got to be very wary of that stuff. But I've probably ingested enough of it in my days. Anyhow, if this video was any use to you, I was able to reuse the flanges on this mounting for this pump, and I'm just tickled to death that this pump is super quiet and will do its job. And this being the testing of this boiler on perhaps what's the hottest week this summer so far in this area. Good luck. This is kind of a PS to the earlier video, which I hope will fit together with the one I've done, since they're rather long. If you've watched all of it, you are warned repeatedly in instructions and that about the use of Teflon tape and even pipe dope and all that stuff. You have to use it sparingly, in my opinion. With the Teflon tape, I didn't really wrap it to the edge of the threads. I backed it out a little bit. Plus, they tell you that it's easy to over tighten something if you use it. I obviously have not had a problem in installing these. I will be monitoring the situation with Teflon tape, if in fact there's any danger in using that. I've never had any issues with it. And I wanted to cover that before some eagle-eyed person in the business would want to rip apart the video. And I'm sure they could find reasons to do it. And that's okay, but I want you to be aware that I know about those things and have studied all the measures of how to install the equipment. And yes, you don't want to over tighten anything anymore, because it's just not designed to be overwhelmed with torque. That goes for automobiles too. And so finally, with the making of this video, I trust that any viewer would know that you must thoroughly understand your system and how it works and the principles of water and all that other stuff to properly manage the equipment. You do not want to run this circulating pump on a dry basis, because it is water lubricated and does not require any oiling, which is another stupendous reason for me to switch to it, because we always had the electric motor pretty much stuck out of this thing right where my foot is down here, and created a burden in walking around this to a laundry chute. In fact, there were times when an article of clothes very rarely could fall upon this equipment, and we don't have that issue anymore, which is a plus. So not only is this pump conveniently small, but it is actually turned out of the way of this little narrow walkway here, which is just great. I can't say enough about how it looks and everything else. I just hope it performs just equally as well as the B&G, which I have no problem with, by the way. Or had no problems with in the way we got service from it. However, there just isn't any noise in this system anymore. In fact, standing here and operating the equipment now, the only noise you hear is the actual burners, which is rather hard to comprehend, because that's the last thing I would have expected to hear was the burners when this thing had the old setup. So that's the add-on for this video. I may think of something else. And maybe a PSS is that when I filled this system back up, I did fill it so that the water filled from the bottom up, which then I knew that there wouldn't be air in the motor, which is the second issue to cover. If you think you're going to lock up something with air in it, you're going to have to deal with that. And it's only a thought process that can make you aware of how to properly place water into a vessel to make sure that you don't trap air below that spot or something to that effect, so that you properly do it.